Sound design.
We talked about this idea of kind of benchmarking system performance. What's the audience coverage requirements? What's the SPL distribution over the audience? What's the target frequency response?
Sound design. Sound Design Live is produced independently by me, Nathan Lively, in Minneapolis, Minnesota. Welcome to Sound Design Live, the home of the world's best online training and sound system tuning that you can do at your own pace from anywhere in the world. I'm Nathan Lively, and today I'm joined by Applications Engineer for Touring Systems at L-Acoustics, Vic Wagner. Vic, welcome to Sound Design Live.
I'm glad to be here.
So, I definitely want to talk to you about sound system tuning, immersive audio, and designing presets. But before I do that, after you get a sound system set up, what is one of your maybe favorite pieces of music to play to just get familiar with it?
I don't think you're going to like my answer here.
I am not going to like it.
I'm a big fan these days of virtual playback. I'm a big fan of once you get the system calibrated to, get some playback from a show previous or some kind of tracks and try to optimize or maximize the signal flow of your drive system. So console to any outboard gear, and then kind of use that as the most accurate stimulus for kind of verifying the system or doing any kind of critical listening.
No, that's perfect. That's the thing that's like freshest in your mind and you're most familiar with because you have been working with it for the last who knows how many days. So as soon as it comes on, you're going to immediately get a bunch of information.
Yeah. Now, my thing is I think it's good to do some ear training. It's definitely good to dig into some hi-fi stuff, dig into some kind of reference tracks and things like that, and think about scale, think about listening to those tracks on different size systems. But that's really just to kind of get an idea for frequency response and kind of how systems respond at different levels. But I think these days, especially in the touring domain, is to really think about using content that's relevant to the production. And I think that's pretty easy to do with modern mixing consoles. I mean, you can do it with a variety of different DAWs, and every professional console allows you to play that back through the system. And I think that's just a good kind of step towards verification to make sure all your outboard gear and everything in the signal flow is working properly and acting responsively as you'd like. So
Vic, how did you get your first paying gig in audio?
This is kind of goes back to, maybe grade school days, kind of volunteering at the community theater. Honestly, just kind of working for some variety shows and mixing my buddies' bands and kind of doing some high school musical stuff, drama club, those kind of things. But I think where it really kind of took form, so to speak, being like, hey, well, this is something that I could do professionally, is working with some regional providers and kind of seeing some guys that build their own speakers kind of in the garage. And that's where I really understood that this is a career path that, is very scientific and exacting, but also musical and offers a fair amount of, I guess, aesthetic leeway, so to speak.
And did you start working with those guys?
Yeah. I mean, it was doing shows, in parks and kind of festivals and things like that, and kind of seeing, they had to get bigger systems and mixing with them and things like that.
How did you meet these guys who were building speakers in the garage? I'm just wondering, like, if I wanted to kind of recreate your path a little bit, like, what are some things I should do to meet people who are doing shows and building speakers?
Well, I think it's a little more professional these days in regards. There's brands that focus on these kind of things, but this was, me volunteering. And as the shows got more complex and, touring artists came in and spec'd larger systems, or more complex systems, we needed larger wedges. And this is obviously in the days of wedges, where I feel like a lot of the stuff is kind of in the IEM domain these days, but, more complex kind of systems kind of comes up. And in there, I think that's where we just kind of expanded, and we had to provide larger systems, and those companies came in, and I was volunteering or working kind of hourly wage at these places for larger productions. And I guess, I mean, you're in Minneapolis, so growing up in the Midwest, there's a lot of kind of summertime festivals going on. So I was involved in that kind of circuit early on and able to kind of see what other people are doing and what touring people are doing.
Sure. I actually grew up in Texas, but the way I see my experience related to yours is that it was really helpful to work in a place where a lot of different artists were coming through, and I met a lot of people that way, which kind of helped me just see how work was done and also just start building relationships that later on could help me find work and do different projects.
Yeah, exactly. Now, speaking to that, I was on a panel a couple of years back talking about kind of getting started and, kind of these questions about how you can get an introduction to this industry. And I remember fondly reading kind of magazines. There's a bunch of trade magazines and stuff and all these kind of journals, and realizing at a pretty young age that there's a world out there of like really professional potential. There's people that are doing this professional. There's better products. There's better, I always kind of think jokingly back to like, these furry box wedges that are kind of the size of a small couch, and that's very homemade, but there's better ways of doing things. And there's a whole world of science and industry standardization that appealed to me. And I was kind of something that I wanted to become more a part of, but I think I wouldn't have been aware of that potential without a lot of these kind of resources. And again, these days, a lot of this stuff's online and, podcasts like this, and
those are all
really, really good.
In a way, we all had and have gear envy. We want to get our hands on that stuff, and you kind of read these magazines and it can kind of feel bad, like, oh, I'm not good enough because I don't work on that stuff yet. But in your case, it also sounds like it was motivational. You're like, oh, there's this whole other world out there, and that's kind of what you had your sights set on.
Yeah, totally. And it was hugely. And I think we need to make sure that those industries are thriving and, students have access to those kind of things and those kind of resources.
So Vic, looking back in your career so far, can you take us to a place where things changed for you? Was there a moment when you decided, okay, I'm going to stop doing this thing and start doing this other thing? Can you tell us about maybe an important decision you made to get more of the work that you really love?
Yeah, I kind of thought about this a lot of different angles, and I could talk about different gigs or different tours I jumped on and things like that. But I think what really kind of ticked in the last decade or so of my career is that I found this kind of reward to really take the time to share my knowledge and experience with others and kind of teach some of these higher level skills and workflows and ultimately just inspire people. And I think that was a really pivotal kind of decision. And I was thinking about it yesterday as I was looking through these questions. And I think that I could identify one place. We were on tour, the big pop tour, and we had kind of a friend of a friend of a friend of the production had asked if we could have some kind of production students from the local college kind of come by and, take a tour. And it worked out really well where we were kind of doing 2 in a row shows. So we'd load in, and then we had that morning to kind of tech stuff and, maybe have some time off and things like that, and maybe get some rest because it was kind of a strenuous schedule. But I took the time to get up early and kind of take these kids, well, I guess college kids and, young adults,
sure,
through everybody was kind of, the lighting guys offered their detail on their system. And then I got to talk about front of house and kind of design and configuration and things like that, and our different system networks and things like that. And I just, all these guys are just really, really inspired by that. And we kept in touch over email and text and stuff over the next couple of years. And I think that was a moment where, I just took a couple hours out of my morning to talk about what I do and what our workflow is. And, these guys were just blown away by that. And I thought, that's a really rewarding feeling. And, if that means that these guys are going to go and get a better result out of their productions or their deployments, I think that can go a lot further than anything else that I can do personally.
So Vic, at this year's Live Sound Summit, your presentation was called Touring Systems, Optimization, Modular Workflows for Efficient Calibration. And that, I think, is kind of a long title for basically saying being ready. And I'm so happy that you talked about this at Live Sound Summit. And if people want to watch your video, they can do that at livesoundsummit2020.sounddesignlive.com. But the reason I was so looking forward to it is because you and I had a conversation earlier this year in January, February, I think, where I asked you, like, what is the biggest challenge you see other people having out in the field? And you said something to the effect of people are kind of not ready. They need to be prepared for any eventuality. They don't have enough information. They're not flexible enough. So things change, things go wrong, and they're just like not ready, not handling as well as they could. So Is that how you see it? And if so, how can I kind of think through some of these things and be prepared without just learning them all the hard way and going through, all the thousands of mistakes that you and everyone else has already gone through?
So I think what this kind of comes down to is identifying a workflow, identifying a checklist. And from the start, when we kind of talked about in the system optimization presentation, is looking at collecting information, talking about specifics to calibration, verification, and then calibration, but having kind of a checklist, a mentality of a checklist and a plan. And I'd say the plan of, acquiring information and making sure certain parts of the system are determined and scaled adequately so there's not any issues as we go through the verification process. And I think, at L-Acoustics, we spend a lot of time kind of thinking about this stuff internally and definitely teaching that in our trainings, and then obviously kind of providing vertical solutions so people can use this within our ecosystem. So I think it's pretty easy for small deployments, but it becomes critical to stay sane and kind of keep on task and have a comfortable workday when you're on tour. So it's even more important in those high pressure environments. And that was kind of one of the things I wanted to really bring to the Live Sound Summit and really kind of expose to the masses and kind of start a further conversation about this.
Yeah, so that makes a lot of sense to me. Work from a checklist, don't make assumptions, have a plan. So the first thing that I wonder is, can I just use your checklist? Like if I just had a copy of your checklist, would that work? Or would that not mean anything to me because yours is so personal? Or I guess I'm also realizing that a big part of your job is probably helping people build their own checklist before they go out on tour so that they have a plan.
Yeah, you said it. That's definitely, helping people build their checklist and kind of work through those things. So I think a lot of that kind of comes down to pre-production planning. We talked about this idea of kind of benchmarking system performance. So like thinking about what's the audience coverage requirements, what's the SPL distribution over the audience, what's the target frequency response, and how does that fit within different fill systems or coupled systems like flow and subwoofer, ground sub, those kind of things, front fill, out fill, delay speakers, identifying those things across the board. And then looking at where the mix reference position is, and then kind of consider source type and like what are the maximum SPL requirements? Where do we need to stop coverage, start coverage? Is there any kind of mitigation if it's an outdoor venue? So I think those are all really, really important things. And then, then I think that's, you want to determine the quality or the type of output busing. Like I said, it was a very, very stereo mix. Is it dual mono? Is it an immersive mix? Is it left, center, right kind of arrangement? Things like that. And you want to identify those things and ask a lot of tough questions and, go through the process of designing different renditions or kind of being able to scale different parts of the system to adapt to those kind of things to put the best solution forward for the bid or, for the rider, and kind of think about those things as far as, and like, I think that's one thing when you asked helping people is kind of thinking about how to scale through our product range. So one of the things I just put a little quote on here is like, when the only tool you have is a hammer, every problem is a nail. And I'm sure you've heard that before, but not every show needs to be deployed with a bunch of K1 and KS28, things like that. We want to think about what are these frequency response requirements? What are the SPL requirements? What are the coverage requirements? And maybe we can do something that's a little less invasive and provides a higher quality experience for the audience and the obviously client.
I see. So when you say modular workflows, then there's parts of it that are going to change depending on certain variables. So can you kind of give me an example of that? Is that related to benchmarking? Or I guess you just gave us an example, which is you might not need all of the front fills that you had in the last location.
Yeah, exactly. So examples of the kind of modular stuff, then I think what we want to do is kind of build into the system some flexibility. And I think that's one of the things is kind of have some quick ways to pivot if something changes, if there's a different audience configuration or different seating configuration, or maybe like a VIP area that you didn't anticipate or something like that, have those kind of things. But as far as verification before the calibration process, I definitely think we want to think about obstacles that can disrupt our workflow. So power everything up, make sure everything has adequate power, make sure network is connected, make sure your file is correct, your network manager file, for example, before you send that stuff. Make sure the left is going to the left amplifiers, the right is going to the right for those kind of systems. Everything is bussed and summed properly if you're doing any of that kind of stuff out of the console. So I like to say kind of a go, no-go checklist policy of, are these items on the network? If they're not on the network, like figure out why. Is there under voltage, over voltage issue? Check those kind of things. And being kind of a space nerd, I think we want to think about aerospace safety. Checklist, a culture of checklists, a pre-flight kind of list, and think about, okay, if this isn't working, we need to identify that problem before we get further in our day and it becomes more of a looming concern that's going to slow down your workflow.
I see. So in part 2 of your process here, modular verifications and calibration, it gets as detailed as here are all the things I'm expecting to see on the network. And so potentially if this amp doesn't show up and it's throwing some kind of error, now's a good time to solve that instead of moving forward and just hoping that it'll get solved and then it becomes a bigger problem later on.
Yeah. And I like to think too is okay, well, maybe there's a problem with one of the amplifiers on house left. Maybe you or someone part of your kind of touring crew or whatever can look into that problem while you move on to a different task and then say, okay, let's get that sorted out. Maybe I'm going to calibrate using the right side of the system, or I can move into another kind of part of the checklist, another kind of chapter of the checklist, maybe verifying all the front of house outboard gear is working properly and set to the correct positions after being bounced for 1,000 miles down the road while the problem's being sorted out on house left or house right. But I guess I'd hate to see a situation where you start the calibration process and realize that a portion of the system's not working properly or not working at all. Let's just say, for example, one circuit isn't passing audio out of the system, and now you're in a situation where the wavefront integrity of the system isn't actually how it was predicted when you did the design in the morning. So I think that's something that we want to kind of avoid, so we're not chasing our tails or making decisions out of incorrect data.
Sure. So these checklists are designed to help us remove as much human error and mistakes as we can. And so that's what I want to talk about now. I'm guessing that you have seen a lot of things go wrong and you've made mistakes, and that's how you've, really developed this complete process of how you should do pre-production and be prepared for anything. So I was wondering if you could share with us maybe one time that something has gone really wrong for you.
Yeah, oh man, there's a lot of good examples here. I mean, I think that some of the stuff is, I think that one of the best things about touring is, you kind of try some stuff and you say, well, that didn't really work that well on this today. So we're going to try to rethink that strategy for tomorrow, and we're going to do a better job of executing that plan in the future. So you can take the whole rig down and reconfigure the system and kind of come back the next day and fix any of the mistakes or any of the disadvantages of the system going forward. But one of the actually pretty funny. I was on a tour and the pop star had a iPod Mini full of music, and this thing was probably 5-6 years old, out of date. And I guess we have a lot of, at front of house you have a lot of computers, and there's a lot of record computers and playback computers and different computers running different levels of professional gear and prosumer gear and very consumer gear. And so I get my 1/8 inch to XLR or whatever doohickey we need to have to get this to plug into the console. And I hit play, and I had some guests at the show that day. So this is kind of before doors, and we're chatting and go out to catering and get some lunch. And I get a call on the radio. So there's a problem with the walk-in music. What's going on? I go, okay, well, I'll walk out there and see what's going on. And it turns out that what I had done is hit repeat on that song instead of the entire playlist. Mm-hmm. So this Adele song played for an hour and a half. And meanwhile, Popstar's Twitter feed is just blowing up with what's up with Adele? How come this song is on? And it's at the Hollywood Bowl. So it's a pretty high profile show, so to speak. And my clunky fingers had just clicked the wrong button, and kind of entertaining guests and stuff. And I had managed to put this song on repeat. And walked away to catering for a duration of time. And now everybody, management down, was furious at me.
It's amazing that it took that long for someone to notice.
I mean, people noticed all over Twitter. It was a whole thing. Twitter and
So the
social media
audience
were
noticed,
blowing
but
up.
no one working there did.
Yeah, exactly. Eventually, management took me in the office and dressed me down pretty good
Oh,
about how
man.
stupid I could be, and so
But you kept the
you know,
job?
I think, well, yeah, and I think that was kind of one of the, I guess, more of a psychological or sociological kind of lessons for me was, you know, they came in, and these managers are under a lot of pressure because it's a pretty high profile show, and, you know, let me have it and yelled at me for 20 minutes and, you know, told me how bad of a system engineer I was and sound guy and, you know, everything else. And I just kind of, I tried to stay calm, and I apologized. I said, I'm sorry, it's my fault. It won't happen again. And I just told them that. I think the best thing was just to not to pass the blame, not to blame any of this equipment that we were using. And, you know, it was entirely my fault for not maybe reading the instruction manual on the iPod mini from 2001. And, you know, one of those things where I just kind of brush it off and continue on with my day and make sure that mistake doesn't happen again, you know? I thought that was a pretty good, kind of laughable, pretty low-key kind of thing, but at the time it seemed like the end of the world.
Oh
for
my
these
God.
people,
Yeah.
so.
I mean, I was laughing with you about it, repeating over and over again until you started talking about the meeting where people are yelling at you. Because then I'm thinking about the meetings I've had where people have yelled at me, and I'm like, oh God, I feel terrible now.
Yep.
But yeah, you're so,
Yeah, and
it's so true. It's so hard to not just try to make the guilt go away by directing it somewhere else. Like, well, that person shouldn't have given me an iPod. That's ridiculous.
Exactly. Yeah, and I think that's one thing is, okay, well, maybe we should kind of rethink how we're doing this, rethink how we're playing house music, and, you know, use something that's a little more professional and less prone to fat finger syndrome.
Sure. So that went on your checklist.
Yes.
If an artist ever hands me an iPod, figure out how to not use the iPod.
Correct. And, like, you know, not to mention the 20-year-old battery or whatever, you know, goes dead. So you have to have some kind of adapter. And of course, you know, Apple changes the type of power connector every couple of years. So you have to, you know, dig around to find the correct adapter. It's one of those things where a lot of professional gear, but a lot of times it's a lot of consumer level gear that you're using on these tours.
So Vic, I've been trying to kind of keep my mouth shut and also maybe talk faster than normal because I usually try to get people to send me questions ahead of time. So I'll post on, you know, LinkedIn and Facebook and say, hey, what questions do you want me to ask Vic Wagner? So many questions came in for you, like way more than I've ever had for any other guest. So either, you know, the L-Acoustics product is either like, you know, very exciting or controversial or both. But people had a lot of things to ask you. So I want to get into those because I thought, you know, they're good questions and also just, you know, want to satisfy people's curiosity. So thank you for agreeing to talk about some of these. You know, some of them are kind of maybe too general, and so we'll see just like how can we speak to them? But you're used to this, so.
Yeah, absolutely.
All right, let's dive into it. So Kyle Marriott, can he explain how they reached the published specs for Cara 2, please? What stimulus, for how long, downhill with the wind, etc.? And I put under here another question. Okay, I'll get to that in a second. So yeah, he wants to know like the, I guess, measurement process for getting the things that then get published on the spec sheet. But there's a lot of things on the spec sheet, so I guess I should have asked him what he wanted you to focus on. But so I guess you can pick, like, what do you want to talk about in terms of what goes on the spec sheet and how those numbers are arrived at?
Yeah, you know, I think one of the kind of things that we pride ourselves at L-Acoustics is doing a lot of critical listening. So I'll talk about some of the kind of product goals we think about, and you know, where do we want a new loudspeaker or product that we're developing to kind of fit in the marketplace or in our ecosystem or our kind of our lineup of products, whether that be K series, you know, like K1, K2, Car 2, or like coaxial. Things like that. So you kind of think about what the form factor is going to be, what the restrictions are going to be, and then kind of start the design process. And then you want to specify drivers, elements, and kind of loudspeaker enclosure sizes and things that are going to work out well for touring, and if that's the market you're going for, and then start development. I mean, again, we're looking at some anechoic information, some interpolation between the different drivers and polar response and stuff that kind of happens at the R&D level. But ultimately, I think what we like to do as a team is develop a system and kind of have a preliminary product, and then, you know, have some listening and really kind of think, does this sound good at different levels? How does it sound coupled with different or a proposed kind of subwoofer system, things like that. So it's a very, I would say, musical and kind of organic process, and take some notes and think about different kind of features we might want to have, whether that be acoustic or kind of rigging bits or rigging features. So that's one of the things. Now, again, Cara 2 is a little more complex as far as published specifications. Again, all these line source systems are elements that are coupled. Sorry, they're elements that are coupled within a larger line source. So
They don't normally exist by themselves.
Yeah, and if they do, we've got a couple FI fill presets. _FI would be in the preset library that are optimized to operate independently or as single enclosures. So when we're thinking about this published specification, we really need to look in prediction to see how they operate cumulatively with other sources in a line or other elements within a line source. So, and then with Cara 2, there's these pan-flex fins that allow you to adjust the horizontal directivity. So I just pulled up the specification sheet. I've got it here, and I see that the maximum SPL is listed at 142, and it's noted that this is defined with the Cara 2 70 preset. So what's going on is those pan-flex fins are mechanically increasing sensitivity in the high frequency domain. So again, that's how you get that higher SPL, but there's going to be a different sensitivity if you go to a wider, so there's just literally less surface area on the waveguide. If you go to, in the case of Cara 2, you could go asymmetric 90 or 110 coverage. So I think you have to kind of think about what your design objectives are, think about how these elements are functioning within a line source, and that's probably the best approach.
Okay, cool.
So I hope that kind of helps answer the question.
Yeah, I mean, that wasn't where I thought you were going to go with it, but that's cool. It's kind of like you almost have the specs ahead of time, and then you say, okay, what do we need to do mechanically, electronically to make this work out? Now, Kyle did specify, he's curious, like what stimulus was used and how long. Do you know what he's asking for there?
I guess some R&D stuff would be, looking at peak noise, looking at some sine sweeps, prescribing I guess kind of some fluid dynamics for subwoofer systems, or looking at some more complex kind of airflow things in the porting. So I think, without getting too kind of in the weeds as far as the R&D side of things, there's a variety of different things that go into place, and a lot of it's these days is done in prediction. Using kind of computer models and like I said, kind of fluid dynamics models to look at how things, especially for low frequencies or longer wavelengths, kind of react within porting and heat dissipation and thinking about crest factor, so to speak. Mm-hmm. So, again, I think that's one thing. If we wanted to get more into it, I could discuss that exclusively. But I think there's other people in the R&D team that could speak to this much more in depth, okay, so to speak.
Great. Well, I'll just ask a follow-up question from Lee Stevens then, who says, especially as they use the same components at Cara, how have they achieved the extra SPL? So he's saying that Cara and Cara 2 have the same components, and yet Cara 2 has a different SPL on the spec sheet. Is that what he's asking?
Yeah, exactly. So what he's asking about is this difference from output SPL because of the different waveguide used, or the flexible waveguide, the pan-flex waveguide used in Cara 2. So I think the important kind of term here is mechanical sensitivity. So we're just increasing the surface area, increasing the radiating surface area when we're talking about line source systems. And obviously that's going to affect the horizontal, the kind of the polar response, the horizontal coverage, like we talk about 70, 90, 110, but also allow you to kind of use this system to accomplish a different SPL distribution goals, to maintain consistent SPL distribution for most designs. So that's kind of how the components are the same. And I think one thing that's kind of commonly known is this upgrade kit, allowing you to take your existing Cara and upgrade them to Cara 2. Okay. So we just changed that waveguide, and then we use the same transducers or motor components to get the same results. Just the different waveguide allows us to get a little more extra SPL if desired. Now remember that this is in the high frequency domain. So below 1,000 hertz, the 8-inch drivers in the Cara, everything is going to perform the same as far as output SPL. Okay. So we're only mechanically increasing high frequency output SPL because it has to do with the waveguide especially.
Got it. And since you mentioned waveguide, should we jump down to this kind of difficult question from Eve Smith? Let's see if you have anything to say about this. He says, I've asked this before during the release demo of the Kara 2, and none of the staff on the convention or demo could give me a definitive answer. Can I combine Kara and Kara 2 in an array? Using the new presets or a combination of old and new presets, I'd love to use the upper boxes with the narrow dispersion and the lower with the Kara 1, which many companies already have in stock. Because the boxes are the same except for the upgradable waveguide, the no, you can't do it, but I can't explain to you why answer sounded to me like he was just trying to sell the waveguide. So would love to hear the technical details. Not everyone has the money to upgrade all their Kara stock. And this way, maybe with some pre-delay. So if I'm understanding this correctly, I think he's kind of asking, can I do this without the upgradable waveguide if there's some other preset or some other way to accomplish it? Is that how you're understanding the question?
Yeah. Now, obviously, it's difficult because I'd love to tell customers and tell people that these engineers kind of anything's possible and we'll customize this and customize that. But remember that if you model an array in Sound Vision, so if we model legacy Kara with Kara 2 within the same line source, there's going to be different coupling and kind of Fresnel parameters that Sound Vision's taking into account. And the software doesn't allow you to combine those because there's honestly different acoustic properties, different presets that are derived that have been updated between Kara 2 and original Kara. So the results would be difficult to predict in Sound Vision, and I think that's one of the things where there's only so many kind of choose your own adventure logic flows that we want to prescribe in Sound Vision, because essentially within the same line source, these sources are going to act a little bit differently because of that different waveguide.
All right, Eve, don't do it.
Yeah. But now I think what's important to realize is that if you've got these Kara, let's say as an outfill, and then you've got another, maybe like a 270 fill, and you've got another like rear hang fill, and one's Kara 2 and one's Kara, we're going to be able to predict those two systems, and they're going to have the same kind of sonic fingerprint that's the same between the two sources. And that's an important goal to us, to make sure that legacy Kara is going to sound similar, or they're going to be kind of backwards compatible when they're used in independent line sources.
Line. Okay, cool.
So I think that's something where, if he's in a pinch and there's a situation exactly like that, he could reach out to us and we could probably offer some recommendations. But again, it's difficult because we don't have the ability to. You can't. That's not a logic path in Sound Vision, so it's hard to. We're making a lot of assumptions about interferences in the near field without that information in Sound Vision. So,
Dave Gammon has a few questions for you. Immersive sound is a huge new area of development. Do they see all large format production moving to the Lisa format?
Yeah, I like that question, and I like. I agree. It's a huge new development. But the short answer is no. I think it depends on the priorities of the production, the artist, the mixer, and even the vendor. So that's kind of the short answer. So again, and I think one thing that's just, I'll kind of break down all of those. Again, the production, may not be interested, and their priorities may be in other things like video or automation, things like that. So, maybe the extra complexities or the, changing from the status quo. I mean, a lot of it kind of comes down to is just aversion to change. This is the way we've always done it. We've made lots of money in the past. We're not going to change anything in the audio department. And I think everyone in our industry has kind of heard that in various forms over their career. So that's one of those things. Again, the artist may not see this as something advantageous. So I think that's one of the things, and a lot of these decisions kind of come down from production of the artist. Now, again, a mixer, I think this is a little more kind of in my lane as far as things I deal with a lot. So I think what's important here is that many front of house mixers developed kind of a resume and on their artistic abilities to manage comparative levels of inputs, and then also work with kind of dynamic range and compression, frequency response limitations that are suited to dual mono mixes or stereo mixes. So again, if that's kind of your niche on your resume, then the ease of use or the high definition kind of deployment where we're dealing with more of a immersive mix or a spatial mix, where that's some of these things with carving a hole in the frequency response of different inputs and dealing with managing the dynamics, the limited dynamics of a dual mono system, especially when you've got a lot of inputs that arrive at the same bandpass and same kind of loudness, And, again, those are all kind of carryovers from the studio environment, where we've got a stereo system, the status quo is stereo, and we're going to do different tricks to those mixing buses to get different things to stand out because our limitation is stereo or dual mono. So I think that's one of those things. And then obviously vendor, that's one of those things too. Again, the knowledge base of the vendor, that's something that they might not be interested in pursuing. So again, to assume that everyone's going to adopt this technology right away, I don't think that's really, personally, I don't think that's an assessment that can be made. So
he also wants to know why L-Acoustics decided to develop its own measurement platform. So you guys have the P1, M1 now, and I guess he's wondering why you did that instead of just adopting, I guess, any other audio analyzer out there, your Smart Sat Live, FIR capture, etc.
Yeah. So let's see here. Where do I start? In the touring domain, I think that one of the things is basically blasting pink noise through a PA for hours is pretty lame. It's definitely disrespectful to other departments. So that being said, is what can we do and what's known about the system already? And, there's a lot of vertical integration with the L-Acoustics ecosystem as far as the drive system, let's say P1 going to some amplified controllers, and then a preset that's designed specifically for that speaker. The performance of the system, the tonal balance of the system is already known in prediction. So there's a lot of knowns about the system already, and a good amount of information kind of known about the atmospheric environment that the system's operating in. So I think what can be said from there is that we have so much information available that we just need to kind of build an environment, or the decision was made to build a piece of software to kind of automate that data collection, look at user evaluation, and then kind of match that with the control capabilities already existent into our network manager, in LA Network Manager. So that's kind of where M1 is born, is there's all this data kind of already available, and that improves the coherence or the quality of the transfer function. And I mean, again, other FFT analyzers, they're good and they have a lot of functionality and they're great, but they are assuming that there's so many unknowns about how the measurement compares to the actual performance of the loudspeaker that's being tested. If that makes sense.
That's interesting. Yeah, it does, because I'm understanding that it was actually the next logical step if the system already knows so much about itself. And really the next missing piece is knowing, what the response is of the system at this point, where this microphone is and where that microphone is. But otherwise, it already had a lot of that information. So it wasn't like you were building something from the ground up. You were really just adding another piece of the puzzle.
Mm-hmm. Yeah, and I think, there's a couple other things where you can collect data and save magnitude data with minimal noise and more accurate acoustic stimulus. So you're going to run a bunch of sine sweeps, collect this data from a bunch of different measurement locations, and then you can use post-processing to really predict, look at coupling, look at equalization results with better statistical averaging, because you can collect a bunch of information about the system at different places and see how the system's going to perform in the front of the room versus the back of the room. And then calibrate that system, either connected to the amplifiers or do it offline. I know, like for a lot of installations and stuff, come in, collect acoustic data, and then go back to the office and actually calibrate the system, or do this online as well,
sure,
where you're connected to the amplifiers and you're pushing the system in real time, pushing settings to the system in real time, and then allowing the user to say, well, let's see how, say I fire up my virtual playback and I start listening to the system. Let's see how these different options react in different parts of the coverage area. So I think that's a good takeaway for how to optimize using M1 for sure.
And just to wrap up, we're already getting into it, but Dave asks, why do you use sine sweeps for your measurement stimulus instead of broadband signal like pink noise? But you've already mentioned that it's faster, so it doesn't bother people as much, and it's a very robust stimulus. Is there anything else you wanted to add to that?
Yeah, so this concept of kind of making sure the system, the transfer function is linear. We obviously are going to put this stimulus into the system. It has a discrete asynchronous start time, and it excites each frequency along the way. The transfer function in the phase domain and time domain can track that. And compare that input to output, just like transfer functions do, or FFT transfer functions. And so this results in a better signal to noise or a more linear response. So obviously it's up to the user. And part of that whole like validation process I was talking about is making sure that input stimulus isn't clipping the inputs to the amplifiers or outputs to the amplifiers or your measurement microphones and things like that. So those are all important things to check before you begin. So I think that better signal to noise is kind of one of the bigger selling points, and obviously results in better data collected.
Okay, Tom McKean says CACOM. Why? So CACOM is a proprietary cable connection multi-pin system, right? So I guess he wants to know why you guys decided to make your own.
So partially historical, also kind of a reliability thing. Dating back to the VDOS days, the KCOM connector was picked over other ones, other types of connectors. So again, this is before the era of NL8 connectors. I think back then it would have been EP4, pretty common, or EP8. So if you guys have ever had the exciting job to, climb some speakers or land a PA and kind of correct any of these dodgy connectors, it can be quite frustrating. So I think that's one of the things is we found that connector to be quite reliable and, somewhat watertight, durable over the years of touring abuse and things like that. And I think anybody who's, especially in the touring world, you kind of get in the habit with NL8 connectors or NL4s, putting this back twist on the cable so it doesn't unplug itself when it goes up in the air. So because maybe that little pin the little locking pin is missing or about to fall off.
Oh, yeah. And parts of those are often plastic, right?
Oh yeah, yep. And so if you're doing a Canadian run in January and negative 20 degrees and all that plastic is brittle out of loadout, that you run the risk of breaking all these connectors. So try to get a solution to our customers that's less fragile than those kind of things.
Chris Prendergast wants to know how the wave sculpture technology has developed over the decades, specifically for L-Acoustics.
Yeah, so I think there's a couple things here. This is actually a lot to unpack, because this concept's been the same. Again, thinking back to like some early 90s white papers where, using this stuff, the physics hasn't changed at all, but our ability to kind of look at more computer modeling, improve the industrialization process and scale that waveguide, the WST technology, wave sculpture technology, into larger products, into smaller products, evaluate things like harmonic distortion, or resonance, things like that. So obviously we're able to look at that on the vertical domain, provide for the line source systems kind of inter-element angles that optimize on the vertical domain, and then also do better to control what's going on in the horizontal domain. So like we talked about with CAR 2 earlier, is looking at introducing PanFlex, for example, where you can control not only output sensitivity of these line segments, but also the directivity in the horizontal domain. And then obviously making sure that maintains consistent and predictable polar response that's predictable in sound vision, and then the sound vision results are translating accurately to that physical deployment. So I think a lot of it comes down to better information and more consistent results because of software development.
Ben Heavenrich says, in his opinion, what separates L-Acoustics from the rest of the pack?
So I guess I'll start. One thing I kind of wanted to point out now from the system calibration workflow from the Live Sound Summit, we'll kind of start with some of the more technical things that I think system engineers can appreciate. So the systems are designed, they're musically voiced loudspeakers. There's inherently more low end, or the available resources is there. We provide tools for you to adapt low frequency to high frequency. So generally speaking, you're going to have the ability to have a full range system that's going to perform musically, and that takes place throughout the entire product range. So that's an important thing for us. It's an important thing for our users, and allows you to be able to say, I want to have the same frequency response for the fill system as I do for the main system, and still be able to use our systems and have the same musical response. Or let's say you're doing a stadium show one day and then you're doing a ballroom show the next day. That frequency response is going to stay the same no matter what products you're using. So that's important to us. Another thing I just spoke on is kind of the prediction side of things. So we've got a predictable output frequency response, and directivity is linear at all operating sensitivities. So again, we're taking into account the system operating at very, very low output and then going up to its maximum output and still performing the same without breaking apart or port distortion. I'm sure we've all heard subs sound like they're farting or something like that. So we try to minimize that and make our systems as linear as possible. And I think touring, I see that a lot, and kind of going back to the M1 conversation and looking at smart and things like that, is you see a lot of people that calibrate systems at very low SPLs because it's comfortable, and then the system is operating at very, very high SPLs. And portions of the system can't keep up with, or I should say other band passes of the system or other fill systems can't keep up, and the entire system starts to lose its linearity. And that's where customers or front of house mixers or people start to get disappointed with the performance of our systems. So that's really important to us. I think that's a thing that separates us from other manufacturers for sure.
Okay.
So a couple other things then. We talked about frequency response, and I think in my capacity right now, one thing I pride myself with, and I know our team prides ourselves with, is listening to customers, listening to users, getting feedback from them, thinking about new features and kind of quicker ways of doing things or better ways of doing things, and quickly and consistently updating and making improvements to our software, which is obviously easy. Just download new updates. And I'll say it on this and to many other people that we do these updates about every 3 months. So if you've been out of the software ecosystem, our software ecosystem, for 3 months, it's best to download whatever's latest and read the release notes.
Okay.
And then also to hardware, what makes these systems easier to deploy for people, what are features that people liked, people don't like, and try to, listen to our users, listen to our customers, and make changes fit their needs. So I spend a lot of time listening, try a lot of time taking notes and trying to feed that into the R&D team. So
that's great. Okay, cool. Stagecraft says, how do they design their presets?
Okay. We talked a little bit about this with the Car 2 question, kind of looking at input stimulus. But I think what's important about this is I'm just going to kind of go through the first part, and we talk about this a little bit we talk about like in sound vision, where we have our pink noise as our stimulus, and then we're going to take into account amplifier headroom, and then kind of crest factor to account for transients. And then we're going to kind of design backwards. So what are the frequency response goals? What are the sonic parameters, acoustic parameters of the loudspeaker? Mm-hmm. And then what are the power supply requirements of the amplifier? What are what kind of transient information we need to have at all frequencies, and specify transducers, specify an enclosure that accomplish those things, and then even down to inter-element angles, kind of thinking about what can we do to have a smaller system that has more flexibility with total curvature, so to speak, within a line source, while maintaining good WST criteria. So kind of thinking about that, and then thinking about trying to keep things simple, trying to keep maybe a handful of presets. Like we said, we use for Car, there's Car 2 is like Car 70, Car 90, Car 110. If you're going to use it as a fill, a Car fill preset, and those have different parameters, but it's easy to like load that. And a lot of touring people these days are actually just designing the system in Sound Vision and then just importing this directly into Network Manager, and that carries all the presets that you've specified for the different use cases right in, so you can load that to your network. So try to keep it simple, and then obviously critical listening. So take this out, have a listen, have the R&D team and the design team kind of make adjustments to the presets, obviously try to stay within a latency quota to account for other kind of FIR filters and things like that are going on to maintain good polar response. And then going back and kind of thinking about, what can we do to improve this? And then come out with the best product, best foot forward as far as the presets. And then after release, then kind of getting feedback, and if there's any kind of changes or improvements. And I mean, this kind of happens as technology improves and predictive and measurement capabilities improve, and try to make things that are going to be better, and release new presets, not too frequently, but if there's a thing that we can make improvements from a software push, then we'll explore that. So
B Miners has a question for you, and we'll see if you have anything to say about this, because I feel like we may need some more information. But he says, how to achieve tonal balance with smaller line arrays, 6 to 9 caras per side with 3 elements, at 1 amp channel. So smaller system and kind of the maximum number of elements per amp channel, it sounds like. Do you want to say anything about how to achieve tonal balance?
Yeah. Now, again, you're somewhat limited with 3 elements in a line source, especially with, in this case, Kara. It's a pretty, you're kind of looking at a point source behavior, especially in the low frequency domain. There's not a lot of directivity control in that example. So what I would encourage somebody like this to do is to take advantage of, in Sound Vision, if you go to SPL Target Toolbox, there's a second bandpass view that you can look at any kind of, I like to recommend a low frequency bandpass. So then you can look at frequency response across the audience from 1 to 10K, and at the same time, look at distribution of frequency response at a lower range, so like 70 to like 250 hertz. And again, I find myself designing systems like this for small deployments, and it's important to look at those kind of things and think, what can I do to make sure that high frequency stays consistent or predictable with low frequency. So I would definitely recommend that. And I guess kind of going back to the question about what sets our products apart from others is we want to look and design the best mechanical solution before we go into the world of adding electronic coloration to improve a problem that could be fixed with a mechanical solution. That allows us to look at that stuff in Sound Vision. I think that second bandpass is a super useful tool.
Okay. So Christian Frederick has a question, and I know where he's getting this from. So there's a lot of great training videos on YouTube now from L-Acoustics. And I remember in one of them, we learned that with L-Acoustics, gain shading is a big no-no, and yet you can combine sometimes different boxes in the same array. And so Christian says, if smaller boxes are used for downfill at the bottom of the array, won't that produce the same problem as gain shading?
Yes. So that's kind of taken into account in the R&D process, where, especially in the high frequency domain, where we have a lot of interferences between these different waveguides. So what we want to do is design a preset that has a constant latency, and when you load, and let's just say for the case of K1 to K2, when you load that K2 preset, that preset has the same phase response as the K1 preset out of the box. Now, in the case of, let's say if you're going to do Kara below K1 or something like that, you need to make sure you load that Kara down K1 preset to make sure that those interferences are predictable, and it's not going to cause any kind of steering or anomalies in the wavefront. So I think what's important about this is we want to encourage the use of mixed arrays, or at least in my designs, my designs and kind of what I find, at least for touring and rental systems, is essentially remember that as we get closer to the front of the room, there's the proximity to the system is increasing. So obviously in the high frequency domain, the system is going to have higher sensitivity or higher output at that position in the front. So naturally what we can do is use a box that has less output capacity. So again, it speaks to the idea of going from K1 that has a higher output to reduce the output of the system by just mechanically switching to a less powerful loudspeaker. That accomplishes the same thing that I think people would have a tendency to use gain shading to accomplish. Now, there's kind of a parallel conversation with this is what we want to do is when you get close to proximity to a system, a lot of times we don't have a lot of control over ultra low frequencies depending on the geometry of the line source. But in the high frequency domain, we can use FIR attenuation that's constant latency. It's accounted for in the preset latency to reduce SPL output in the high frequency domain. So we want to be sure we're using that. And if you're calculating, call it auto FIR, it will take into account array geometry, audience geometry, and atmospherics. It will prescribe a set of FIR filters to normalize or reduce these kind of spots in the coverage area that are caused by high frequency building up because of the mechanics of the line source.
Okay, so Dan Barrett says, how many toddlers does he think he can take in a fight?
Well, like I said, growing up in the Midwest, I played hockey as a kid, and that was one thing I kind of learned is a lot of those smaller guys can run right around you, and so probably not very many. I'm a pretty big guy, and I feel like they'd have a pretty massive advantage over me. So not very many.
So Tiago. So Tiago and one other person sent in questions about the K2 and the car and the K3. And Vic and I were chatting before we started rolling today, and we're not going to cover those questions because those will actually be answered in a product release that's coming out tomorrow. So by the time this interview comes out, that product release will already be up. So Tiago and the other person had the question about the K3. Check out the L-Acoustics website, and you should be able to find the answer to your question. Christopher Patrick Poe, Vic's had quite the career being a system engineer for such notable mixers as Scoville and Pooch. If it's within reason to venture outside of the brown box's realm, I'd be curious to hear his opinions on some other rigs he's deployed. I'd say most curious was Anya, as that stands out above others, considering the flexibility it offers in some terms of DSP process steering and control. And I'll just point out that I think if people are interested, if I'm remembering correctly, you can find a YouTube video of Robert Scoville talking about this system, and I'm guessing you were involved with this. Am I saying that correctly?
Yeah, there's probably Robert talking about it and me running around frantically, calibrating the system hours before sound check or something. So there's probably some hilarious footage of me running around an arena with a bunch of microphones and yeah, exactly. But to his question, I think one of the more fundamental kind of things that I've learned through these processes of dealing with different manufacturers' PA systems is to reach out to the manufacturer and immerse yourself in their recommended guidelines and ask them the hard questions as what do you think I should do? Like what manufacturer should I do to optimize these systems or to deal with these kind of concerns I have or deployment questions?
Because they want you to be successful.
Exactly. And they're nice people and you're gonna take time. You need to make sure you allow time to, plan and bounce designs off of them and bounce ideas and not to be defensive, not to be kind of disarm yourself as far as put your learning cap on when you're around these people to absorb as much information. And I think if you kind of use their recommendations, you'll get the best results. And you're talking about Anya and talking about systems I've used with Pooch. I think that was the same kind of thing where there was a lot of new technology that we were testing out for the first time, and they had recommendations, and I tried to be patient and use the systems exactly how they recommend.
Okay. Nico Diaz says, stereo versus mono. If the stereo image is mainly enjoyed by only a few people of the many in a live event, could a single wide dispersion line array provide a more uniform coverage?
Yeah. So I think it's a great question. I guess the technical jargon would be, are these correlated or decorrelated inputs to the system? So what are we doing? Are we looking at like feeding like a paging system where it's a mono send? Is it a stereo send? Or is it something more complex than that, like an immersive system or LCR is a topic of conversation often. So I think that, yes, that's a huge problem with dual mono. It's a huge problem with stereo, that it's not optimized for the populace of the audience. And so we need to think about that in deployment. I think, I'll just kind of say LCR, for example, it's important to kind of think about that kind of thing, to have as much overlap between all three of these sources, so as many people as possible are experiencing the localization of how you have things panned in that field. Now, I think one of the great features of immersive mixing or our ELISA systems is that it accomplishes that a lot easier than having to deal on a bunch of different busing and things like that. There's a bunch of different, and Nico uses the term, this kind of single wide dispersion line source. So what we're doing when we're deploying these systems is we're using a variety of usually like five line sources or 7 sources or something to provide that consistent coverage and tonal balance on the horizontal domain. And then all of those sources are essentially overlapping coverage, so you can place an object in that environment and you can move it and it's not going to change tonal balance or level as you move it through the sound field.
Cool.
So I think that speaks to ELISA, but I think that it's important to think about those kind of things. Also important to think about temporal localization when you're thinking about fill systems. I mean, just remember that there's always a function of delay and level where your brain is going to localize the direction of what source is heard first.
Okay.
So it's a complicated thing even for dual mono and LCR systems to think about, how the bus comes into the system.
Yeah. Vic, do you have any unique or interesting pieces in your work bag that you could tell us about? What's something that you think other people don't have or don't know about?
I mean, I think most touring people kind of know about this, but it's True Pulse rangefinder. That's kind of a standard thing. I think that, always the question comes up in a lot of our trainings and obviously for tours and stuff when that resumes is, how do I measure the room? How do I gather room dimensions and create a quick model? So I think a True Pulse is a good thing, especially if you already have a room model and you just want to verify its accuracy. It's easy enough to do that. In addition, carry a small tripod to put that True Pulse on. So I think those are all kind of things that are pretty small and pretty easy to fit into a backpack.
The True Pulse is the one that has the camera, and so it has a little screen, so you can in the daylight you can see what you're aiming at.
That's like a Leica. I think the Leica A series has that. This is more of a rangefinder kind of handheld thing. And Laser Technology Incorporated is the company that builds it.
Okay.
And it's an optical laser. It's not a red dot laser, so it works through most kind of fog conditions, and I think it goes up to about 300 meters. So it works well for dark arenas to stadiums, when it's the bright sun out and things like that. So other things in the work bag that I think are very L-Acoustics centric. I carry a P1 with me. The P1 allows me to use M1 to calibrate, carry a couple measurement mics. Right now you can plug four measurement mics into the front panel mic pre's of the P1, but I usually carry a couple spares in case one gets attacked by a chair cart or a forklift or something. So
what mics do you have?
That's right now iSimcom 7150s. They're affordable. Sure. They're pretty accurate. And again, the quality of these microphones, but when we're compiling this information, we're relying on a variety of different measurement positions to produce our average. So the more average results you have of the system, if one mic has slightly different frequency response from another, within reason, because we have so much averaged information, the statistic information is better. So, that's the thing. And then the other thing is a little SPL calibrator to make sure those mics are working properly and they're all running the same sensitivity. So we don't have bias towards one data set in the data collection.
Vic, is there a book that you could share with us that's been really helpful to you?
Oh yeah, those are some interesting questions. I guess academically, I think one of the things that I kind of changed my opinion years ago about designing these systems and thinking about optimization is it's called The Complete Guide to High-End Audio. And this is Robert Harley. And I think the focus on this is more kind of hi-fi systems, but I think that the important takeaway from hi-fi systems is you're usually accomplishing more with less. So there's less in the signal flow. You're using really, really high quality components. And that way we don't have to rely on a bunch of widgets to improve the frequency response or improve the desired performance of the system, because we've picked portions of the system or segments of the drive system or signal flow with the best possible pieces and the least amount of coloration or phase shift or attenuation or headroom issues and things like that. So I think that's an important mindset. And, people think, I think a lot of this stuff kind of gets forgotten about in commercial audio and touring stuff. And I think that's really, really important because you're going to get the best results out of the system and you aren't going to have to do a lot of upstream signal manipulation to get the results you want. Second book I thought was kind of a good one to put on here it's called The Idea Factory. And it's by John Gertner, and it's about Bell Labs in the early 20th century, kind of through the 70s and 80s when Ma Bell was broken apart. And this Bell Labs, they kind of wrote the book on a lot of what we deal with in audio networking and kind of our references as far as how decibels work and how we've defined these kind of studio references over the years that we've adopted into the sound reinforcement field. And I think it kind of I like to kind of think of a lot of the problems that you think are unique to sound reinforcement. The phone company dealt with the same problems years ago, decades ago. So I think it's a good kind of humbling story of reading through and kind of and understanding where the concepts kind of came from. Another book that I kind of want to just bring up that I thought was really, really cool is Failure is Not an Option. It kind of goes back to my space nerd things. And this is by Gene Kranz. And he was the NASA flight director during Mercury, Gemini, and Apollo. And he talks a lot in this book about building checklists and building redundancy systems into aerospace, no-go checklists, things like that. Mm-hmm. And I think that's the mentality that we want to encourage and adopt for touring applications.
Cool.
So that's a good one. It's also, if you like physics and aerospace stuff, it's a good read. Not to mention, some crazy failure scenarios where they have to kind of move quick and make some decisions that could potentially equate to the life and death of a crew.
Is there duct tape involved?
So, yeah, I think so. Yep.
Vic, do you listen to any podcasts?
I do. I do listen to a lot of podcasts.
I want to know which ones you have to listen to every time they come out.
Oh man, I got a couple for you. So I'm going to leave the political podcasts aside for this discussion, but one of the ones that brings me great joy is a podcast called Switched on Pop. And what these guys do is they just dissect pop music or take a song or a genre and kind of unpack it and talk about why it's pop and what makes it interesting to listen to, and kind of the evolution of the story and what it means as far as songwriting and so on from there. So that's a good one. And I also think that for a lot of this stuff is having a good understanding of musical instrumentation, and I think that's a good place to kind of start and thinking about arrangements and think about how that translates to how songs are recorded and how the public or the masses kind of perceives how a pop song should sound, and thus how a system should be deployed for sound reinforcement.
Cool. Vic, where's the best place for people to follow your work?
I think the best place these days, you can definitely, L-Acoustics on our website, you can go on there and go to contact and find a picture of me and my email and shoot me an email. My phone number's on there as well, I think, so you give me a call.
Day or night.
And anytime. Yep. I never sleep. But no, I try to keep our customers and any kind of interesting projects that we're working on. We definitely post on our social media in the LA The Best Sound on Instagram and everything like that. So try to keep a steady flow of, especially in the pandemic times, positive and uplifting things kind of happening on a daily basis.
Well, I'm glad you said about people contacting you, because we had so many kind of listener questions today that I think if Vic didn't answer the question the way you expected him to, or there's more information that you want, or I didn't ask it the way you wanted it to, you should reach out to him and then email me and let me know what he said, because I'd be interested to know as well. Because I realize as soon as we get into the interview, this always happens, I realize, like, I think I know what this person wanted to know, but I'm not totally sure. And so I don't really know if I'm steering the conversation in the right direction. So reach out to Vic. He's a super nice guy. And his contact's on the website. So Vic Wagner, thank you so much for joining me on Sound Design Live.
No, it's good to chat. I loved it. So glad I could get the information out there and have this discussion with everybody.
Sound Design.
This episode was edited by Noah Feldman. It features music from an artist named Mellow C. You can find more at chadcrouch.com.
Sound Design Live is supported by Ellis Learn Stage Lighting, Joel Sinqui, Bob, Pedro, Martin, Roadie Free Radio, Scott Ross, Voyager Sound, John, Dave, DC Sound Op, Nicholas, Kuba, Chris, and Terry. You can start supporting Sound Design Live today for as little as $1 over at patreon.com/sounddesignlive.